Next presentation is from Istvan Haynal. He's Insights Director, Marketing and Data Science at GfK Belgium. And Istvan will talk about fusion, not about fusion in the kitchen, but about data fusion.
Okay, thank you. I'm very happy to be here again. So my name is Istvan Haynal, and I'm a data scientist working for GfK. That's a market research company. And I must start with an apology, because I cannot cure cancer for you. But for almost everything which is less severe, we have something for you. If you are interested in TV ratings, let's say, well, we have for you an audience measurement system in many countries, including Belgium. If you're interested in what people are buying, we have a household panel. If you are interested in a point of sales tracking, we have a service for that as well. And finally, we also do ad hoc research. Now, the theme of today is data for good. And I asked around, and it turns out that we do actually quite a lot of data for good at GfK. One of the things that we do is that we have a joint program with the University of Pretoria to do market research training in Africa. We have done the Nigeria population survey. We have co-funded that as well. And generally, we do quite a lot of work, sometimes pro bono, sometimes not pro bono, for companies or organizations, I should say, that have somewhere a social objective in their mind. And I would like to discuss one particular example, and that's from, and now I need to look a little bit here, the Environment, Nature and Energy Department, LNE, which is basically, and again I need to read here, Administration of the Government of Flanders. And they basically want to measure the food wastage in Flanders. So what they want to know is, what are people buying and in terms of food, and what are they throwing away? So not eating, but throwing away. By the way, I tried to find the logo of these guys, and the only thing I could find was 1/3 of a lion's head in black and white with a slogan. And as you can see, I tried to match my presentation, PowerPoint presentation, to their style. And also, these guys are so heavily into recycling that I could not help but notice when I was sitting there that there's a strange similarity here, huh? But okay. Good. So what they want to know is, what are people buying and what are they throwing away? And throwing away, they suggest that we would do that with a diary. So you just give a diary to a household, it's computer assisted, and they have to note somewhere what they chucked away, basically. Good. Now it turns out we at GfK, we happen to have a household panel, so measuring what people are buying, which is the second part that they want to know, is something that we can do quite easily. So the most obvious solution is you just give the diary to your household panel and off you go. But things are not that easy, huh? Because measuring what people are throwing away with the diary, even if it is computer assisted, is quite difficult. You're asking a lot of your respondents, it costs a lot of time. So before you know it, if you're not careful, people will basically drop out of your sample, you will have quality issues and so on and so forth. Likewise, measuring what people are buying is also relatively complicated. Huh? Even if you give them a scanner device, it's rather intrusive, it's time consuming, so if you're not very careful, you will have quality issues, you will have dropout, and so on and so forth. So you can very well imagine that if you combine the two, that will not work. You will not find households that will do the two at the same time. And if you would find these people, those people are probably not representative for the rest of Flanders, huh? So this will not fly. The second thing is, or the last thing there, and that's probably the most important thing, if you are measuring what people are throwing away, you will probably also influence what they're buying, right? And given the fact that we need our sample for all of our other clients, that's not what we want to have. Huh? By the way, that's in market research sometimes referred to as the Hawthorne effect. Okay, so should we then simply give up? I don't think so, because then my presentation would be over by now. Because there's a solution for it, and that's data fusion. And I recognize many of you as data scientists, and it's one of the techniques that you should consider when you are in a situation like I'm describing here. What is data fusion? Well, data fusion is combining relevant information from several data sources into a single one that provides a more accurate description than any of the individual data sources, the official definition. And basically it comes from the area of engineering where they are using this for sensor fusion, but what we do is, I think, a little bit more simpler in the data, in the market research context. So what are we looking at? Imagine you have two data sets with X variables and Y variables, and the X variables, you really should think here about the diary data. Then I have in a separate data set measurements, these are my Y variables, measurements on what people are buying. So if I'm smart, then I have a few common variables, the Z variables here, and I can use these Z variables to basically and try and statistically match the observations from my first data set with the observations of my second data set, so that at the end of the day, I have a combination of the two. That's exactly what I want. You can do that, but you need to be careful about it. So in a little bit more detail, what you need to do is basically first you need to identify your common variables. They're also called hook variables. You then need to do a couple of recodings so that they're all on the same measurement level. Then you need to inspect the correlations, and then you finally need to do some kind of matching. And there you have several options, and I'll just show you three possibilities, but there are more. One of them is just simply using the Euclidean distance or the weighted Euclidean distance. You have predictive mean matching solution you can do, but you can also do something which is called linear imputation. Now, some of you might think, how can imputation work in this context? So let me illustrate that with an image. So look at this picture. You could, if you look at the pixels on this picture, you could in a certain sense see that the rows in my picture are in a sense the cases of my data set, and the columns in my picture are the variables in my data set. So I have a perfectly normal data set as I usually have. By the way, we are in our exercise later on, in the imputation, we will not take advantage of the fact that generally speaking, men have two eyes, and the eyes is above the nose, and the nose is above the mouth. We are not taking that into consideration. So in a certain sense, you could also consider any random permutation of the rows or random permutation of the columns, like this. For us, it's the same picture, right? But let's go back to the original picture, and let's delete 3/4 of the data, right? And as you can see, the quality of my picture has degraded significantly, or substantially, I should say. At the same time, you still recognize that it's a picture of a man. And if you believe in sampling theory, and you should, then that shouldn't come as a surprise, right? But let's all agree the quality is not too good. So what we will do now is we are going to fill in the empty spots here, which is 3/4 of the picture, with data coming from the remaining 25% that you see here, right? And this is with a very simple algorithm called nearest neighbor. That's what you get, right? It's not too bad, huh? It's not completely correct around the eyes, and at my age, I wouldn't mind if they would do that to my picture, but generally speaking, it's not too bad. This is another variant of the nearest neighbor algorithm. It's a little bit better. And this is with linear imputation, which is something which was developed initially, I think, by Rao and some other statisticians, and which was refined at GFK itself. And this is not too bad. So this thing really works. Okay, these are a couple of safety slides. We'll skip them. And let me immediately go to an application. This is one from Germany. And by the way, I cannot show you the results of the food diary thing because this research is still ongoing. So that's why I have to show you an application which is in the area of media research. So in Germany, what we have is we have a panel that measures what people are buying in Germany, just like in Belgium, and we also have a TV panel. So what we want to do here is, let me see. So what we want to do here is make a fusion of the two. And why would we want to do that? The reason why we would like to do that is today, if I look at media measurement, it's expressed in terms of, or let's say TV ratings, it's expressed in terms of gender and ages. But if I am a coffee brand and I want to target my audience, well, men are drinking coffee, women are drinking coffee, young people are drinking coffee, old people are drinking coffee, doesn't work. But if I know who my coffee drinkers are, I can do something. So that's the reasoning behind it. By the way, you're probably asking why is this guy standing up here? Well, I'm just teasing Johannes. Johannes he's been doing this for 3 years now. It's the 3rd time. One more thing. Johannes is from Brugge, but we will not take that against him. Okay. So what's the situation here? The situation is that we have in our panel, in our consumer panel, we have demographics, but that's not sufficient. We have survey TV usage, which is not very precise, but very good as a hook variable. Then we have some additional common variables, and the most important part here is this, measured buying behavior. And on top, we have the data from our TV panel. There we have the same demographics, we have very detailed measured TV usage, and we have some other common variables. The thing that we miss is that part on top. And that's what we will inject through data fusion, right? And I'm already at the end with a few takeaways. The first thing is, I'm quite fond of data fusion, but only if you use it in the right circumstances. And the right circumstances are if there is no other way in which you can collect your data through direct observation, because nothing beats direct observation. So don't use data fusion as a cheap way out of combining two data sources rather than collecting them directly, only if it doesn't work. Third point, and that's the crucial one, the quality of your data fusion depends critically on your selection of hook variables. In a lot of applications, if you only have socio-demographics, it will not work. You need to have something which is more tangible, something which is stronger correlated to the variables of interest. Okay, then during your process of data fusion, you need to make sure that you validate your results. So what you want to have is a situation where some of the key statistics are preserved. And I particularly think about marginal distributions and correlations and so on and so forth. You need to check for that. And you need to select the one that is the best. Another one which is a risk. At the end of the day, after your exercise, you have a data set. And if you are not careful about it, after a time you will forget that your data is coming from a data fusion. And that's a very big danger. So you always should realize, hey, this data is actually coming from a fusion, therefore there are some types of analyses that I cannot do, because otherwise it will not work. So my last conclusion is, for those data scientists here that have not heard about data fusion, go to a library close to you and check it out. Thank you.